Hey folks, so section 9.5 is not going to cover a whole lot of actual Math 111 trigonometry concepts. It's more just going to cover beginning, intermediate algebra, college algebra solving techniques that we're going to use on the trigonometry. We'll talk about the trigonometry in class. All of section 9.5 is going to deal with solving trigonometric equations. I would like to give you a couple of tips first, which is common for me. First tip, get the trig function alone. This is going to be the tip that we're going to use in the very first example here. Get the trig function alone. And the second tip, do not ever divide both sides by a trigonometric function. You can divide by numbers, that's fine, but if you divide by a trigonometric function, you are going to lose some of your solutions. So let's get started right in on this very first example. And again, I'm not going to actually solve the trig equation. We'll do that in class together, but I want to solve the junior high equation that I have set up that looks exactly like the trigonometric function, or the trigonometric equation. So you'll notice that I've taken number 10, and instead of writing number 10 with secants, I've rewritten it kind of like junior high math with a values, so that it says 2a plus 1 is equal to a plus 3. And I would ask, how do you solve for a? Well, you get the a value alone. That's tip number 1. You want to get the trig function alone. We're going to get the a value alone. This is done by combining like terms. So the first thing that we're going to do is subtract a on both sides so that we have a plus 1 is equal to 3. And then we'll subtract 1 on both sides, which is going to give us an a is equal to 2. We'll use that exact same concept for number 10. Instead of getting a alone, we're going to get secant of x alone. We'll get to that in class. The second example is that you can use factoring techniques. And I'm actually going to run into this twice during this video. So you'll notice that on number 12 here, I already have the factors cosecant of x plus 2 times the factor cosecant of x minus the square root of 2 is equal to 0. This is like when in Math 101, Math 102, elementary algebra or intermediate algebra or college algebra, if you have your factors, all you have to do is set each factor equal to 0. So I took my x minus 3 and my x plus 2 factors, I set them equal to 0, and then I just have to solve my mini equations so that x is equal to 3 and x is equal to negative 2. When we get into class, that's exactly what we're going to do on number 12. We'll set each factor equal to 0, and then we'll solve our mini equations. The next example I'm going to skip over. We'll work on that one in class. And I want to go to number 4, where we can use quadratic techniques for solving. If you remember from college algebra in Math 110, you would solve quadratics in 4 different ways. You could solve by using factoring, also known as the zero product property. You could solve by using completing the square root method, or the quadratic formula. And I have reminded you here of what the quadratic formula is in case you forgot it. But when I look at the example here for this fourth technique, and the first thing that I'd like to do is simply take my example and rewrite it without the cosines, just to make it a bit more junior high-ish. And so if I rewrite that with a's, 2a squared plus a minus 1 is equal to 0, and I think about one of my 4 methods, I can use factoring on this technique. So if I can factor this into the 2 factors 2a minus 1 and the factor a plus 1, then this is actually an example exactly like number 12, where I can take each factor, set each factor equal to 0, and then solve my mini equations. So that's what I'll use for this example here. However, when we look at number 40, there's no possible way that I can factor this one. Now, notice that I've taken the trigonometric equation and I've rewritten it using x's instead of cosines. So I have 4x squared plus 4x minus 1 is equal to 0. And I'm going to use my quadratic formula on this since factoring is not an option. So the first thing I do is plug and chug into my quadratic equation. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You might have a song running through your head because there is one that goes with it. And we'll clean that up a bit. so that we have an x is equal to -4 plus or minus the square root of 32 all over 8. I can simplify this further. It's not going to turn out very pretty, and quite frankly, for our trigonometric equation, I'm not going to need to simplify it any further because we're going to be using our calculators on this one since it's not straight off of the unit circle using one of our unit circle values. So we will finish this question in class after we've worked through the quadratic formula, which we just did. Number 44 is also another one that we cannot work through by factoring, so we'll have to use the quadratic formula on this one as well. Notice that I took my cosine thetas and I turned them into a's to make a more normal quadratic equation so that I can plug it into the quadratic formula. So the first thing I'm going to do is simply plug into my quadratic formula. We'll start to clean that up. We'll notice that I have a negative inside of the square root. We know that negatives inside the square root cause imaginary numbers, so that I now have -1/2 plus or minus I over 2. Again, this will take us to the point as far as we can go for the quadratic part, but then we'll take this a step further in class when we go solve for the trigonometric equation. And then 54 is another one. I've already worked this one out for you. You cannot use the you cannot use factoring here. So we would use the quadratic formula. I've already worked this out for you, and we will continue this one in class as well.